record. All right. Hello, everyone, and welcome to this week's competitive programming workshop, C++ for competitive programming. I think this is actually the first time that competitive programming class has hosted C++ workshop. So what does that mean is that I have very little things to prepare from, and hopefully this is going to be good for everyone. I also haven't done public speaking in a long time, so in case I screw up, I hope that everyone can try not to judge me too harshly. So let's talk about C++. C++ is quite fast. It's about 90% as fast as assembly. So this has made it quite popular anywhere when speed matters. Python libraries, game, any CPU bounded application, some of the database, they use C++. However, C++ is also quite complex, packed with features. I think C++ has more features. Its syntax is more complex than any other language that I know. Some of its design is also quite old, and they are showing their age. So what that means is that some people are saying that C++ is quite dead, it shouldn't be used, and some people dislike it. So in that way, it's also quite controversial. Right. So why do you want to learn C++? Well, majority of programming competition only give you 4 programming language: Python, Java, C, and C++. You don't want to be using Python because it's quite slow. It's about 100 times slower than C++. Sometimes that could mean the difference between a linear time algorithm and a n-square algorithm. You also might not want to use Java because it's also quite slow, about 10 times slower than C++. So that's like the difference between a n-log and a linear algorithm. That leaves you with C and C++. Now, if you're using C, right, you might as well use C++ because C++ is basically an extension of C. Pretty much everything you can do in C, you can do in C++ with some minor differences. And C++ have a lot of extra features. It has a huge standard library actually, with all the data structure that you might need and all the formatting thing when you're printing output, etc. And the fact that C++ is object-oriented also make everything a lot easier. So if you're using C, you might have to implement something that is already in the C++ library. So yeah, another reason is that C++ syntax is really complex. So what that means is that like C++, its syntax is so huge and there's so many features in C++ that any other language, as long as it's not like functional programming or as long as it's not from a completely different paradigm, any other programming language that you learn after you learn C++, they appear to be quite easy. They appear to be really easy actually. I think after learning C++, I learned Java in like 5 hours or so. So just in that case, it lays good foundation as a programming language. Another reason is that C++ is quite popular. So there's a lot of jobs that require C++. If you know C++, if you're really good at it, that give you more jobs. More jobs means who doesn't want more jobs, and possibly higher pay as well, since C++ is kind of a complex language to use. Let me just Haskell. Yeah, well, Haskell is another. I think. Oh shit! Yeah. I think most people can hear. People can hear what I'm saying, right? I'm not muted this whole time, right? Yes. Anyone? No. Okay. That's good. That's one of the. You're in the. I am not muted. You're muted. That's like the fear of many tutors and lecturers, that they just talk into the void and they're actually never muted. They actually never unmuted. Right. Where was I at? Yeah, Haskell is quite different from C++ because it's like a completely new way of thinking. And also something like Smalltalk and Lisp, they are also quite different from C++. But the majority of language that you're gonna use is gonna be, they are gonna be very easy compared to C++, and you should be able to learn them quite easily. Right. Let's talk about prerequisites. So this workshop does not teach you programming. We do not have that much time to teach you programming and then C++ in 1 hour. So I do assume that you have some sort of previous programming experience. You know some sort of programming language such as Python, Java, or C. Actually, if you know C, it will be a huge advantage because a lot of the things that you can do in C++, most of the things that you can do in C, you can do in C++. Also, I think knowing a static type language can be quite an advantage compared to knowing a dynamic type language because you already understand what type is. Right, I will be using Visual Studio to do demonstration here, but you can use any IDE you like. For example, VS Code, some sort of editor with GCC. You can even, if you really are too lazy to download a IDE on your computer, you can also go on to some of its online compiler. Just search up C++ online, and there are heaps. There are a lot of online compiler out there. All right. So I think that's all the introduction. Let's get started. I'll just check chat. Oh, okay. Yeah, okay. It is pink. Yeah, okay. Okay. All right. All right. Right. So this is a hello world program in C++. You should, if you already done programming, you should have a vague idea of what's going on. I'll just go through everything line by line. So the first thing is this is a single line comment. This is a block comment. You should already know what comment is. And this is how C++ does single line and block comment. After that, we comes to include IO stream. So IO stream is the standard input output library for C++. This is equivalent in C would be I think standard stdio, and in Java it's like I don't even know what it is. I forgot, but yeah. IO stream stands for input output stream. So what this does is basically it imports this library into our program so that we can use some of its function, some of its objects, and allow us to print to the standard output and get input from the standard input. Right, after that, we comes to the main function. So this is this function is the entry point of our program. It gets automatically executed every time I run my program. So you don't have to, unlike Python, if you have a function in Python, you have to call it here. In C++, you don't have to do that. The function just get automatically executed. So we can see that it prints out hello world, right, from this line of code. So I think I'll just try to explain this. Right, so what this is called a string insertion operator. You don't really have to understand the syntax behind. Actually, I might be able to cover the syntax behind this operator. It's called operator overload. But right now you don't really have to understand this. You should just understand this as putting the string inside cout, console out. So, and then also putting end line in cout. I hope that's clear. This is how C++ print things. Notice that we have std : everywhere. So this is what's called a namespace. If you can avoid typing std : whenever you call something from IO stream by using namespace space SD. So this basically just lets you avoid typing this. I won't really go into namespace in this tutorial just because it's not really relevant with competitive programming. It's also like, yeah, I just don't really want to explain it, but you know that right now. Just remember that typing this allows you to type less for this, right? Let's move on to variables. So in C++, a variable name can contain letters, numbers, underscore, but not anything else. It can't start with a number. This should be quite similar to most of the other programming language out there. C++ is statically typed. So what that means is that before using a variable, you have to declare it. And while you're declaring it, you have to tell C++ what type that variable is. And for those of you that came from a dynamically typed programming background, a type basically defines how much memory a variable will have and how this memory will be interpreted in the code. Right, let's have a look at some of the type here. So this is most of the C++ primitive type as shown here. We have some integer, short int, long int, int. They have each of them has a specified range. So each of them, those, for example, A can only hold value between -2 to the power 15 and 2 to the power 15 minus 1. Int can only hold all of that stuff. If you already know a statically typed language, you should know what I'm talking about. Now notice that how long int, at least in this specific environment, it actually have the same range as int. Now you might want to ask why, why do we have two different type that eventually means the same thing? The reason being that C++, like how many memory a certain type take actually depends. It's actually environment. It's actually system dependent, right? So for example, in a 16-bit system, int might only be 16-bit long. Right now we're in x86, so 32-bit system, this int is 32-bit long. In something like a 128-bit system, this int might be 128-bit long. So all of that, all of that is system dependent, and what's shown here is just what is the most common range of those types. But if you go onto long line compiler, things might be different. Right. After that, we comes to Boolean. So a Boolean, supposedly, it only can contain two types of variable, right? Either two value, right? Either it's true or it's false. However, because there is no true and false in assembly language. So in C++, Boolean is actually a number. When everything gets compiled, true or false will get turned into 1 and 0. And I think Boolean can contain other kind of numbers as well. I'm not exactly sure, but yeah, I think if it contains any numbers, anything that's not 0 should be interpreted as true. Right. After that, we comes to character. So I've defined a character here. A character in C++ can basically hold a single character on your keyboard. This should be quite straightforward. Now, interesting to note about character in C++ is that they actually also integer, because obviously, once everything gets compiled, there's no character in assembly language, right? So what C++ does is that it look at this table. Can people actually see this? I think this might be a bit small, right? How do I enlarge this? All right, yes. Okay, so basically look at this table, which just maps every character to a number, right? So because of that, you can do something that's interesting, such as you can add two characters together. Let me just try this out real quickly. A plus B should give us 195. Yes, see, yeah. So like they are actually equivalent to number. Well, once they get compiled, they're basically they get turned into number. Right. You can also make an integer or a character unsigned. So what does that do is that you're basically telling C++ that this number will never be a negative number, it will always be positive. So what C++ then do is that it takes all of the negative range and it give it to the positive range, and this give you 0 as your minimum value that this variable can represent, and double the range that this variable can represent. Although it's generally not recommended to use unsigned, just because sometimes you think something never go negative, it goes negative, everything breaks, and you don't really know what's going on. This is called a overflow error. So I think I'll talk about overflow once I go through rest of the type here. Now after this we come to floating point. So floating point are basically numbers with decimal place with them. We have 3 of them. Again, their range and how much precision they have actually depends on the system. You can see they have quite a large range. However, the way they're represented in binary is something that's kind of similar to scientific representation. They have a part of the memory representing all the digits and another part of the memory representing the exponent, right? So what does that mean is that even though a float can represent all of those numbers and a double have all of that range, it actually is limited in precision, right? So for example, float only have around 7 significant figures and double only have around 15 significant figures. What does that mean is that if you have a really big number and then you keep adding a really tiny number to the big number, that the tiny number is so tiny that once it gets added to the big number, it basically gets lost in precision. No matter how many times you add this tiny number to the big number never changes, right? So that's something that I think people should be aware of. Right. Does anyone have any questions so far about types? I hope I explained everything okay. How do I get? All right, there it is. Oh yeah, extended ASCII. What does that mean? I don't know what does that mean. Maybe are you talking about Unicode? No. For long int couple should handle this in most cases. Yeah, okay. Does anyone have any? I am assuming no. Okay. Let's move on. Type def. Yeah, I did not plan for that. I think me personally, I never use type def. And okay, so actually let me just go through that real quickly. So type def is basically, I think type def is like a way to like give a alias to a type, right? So maybe I can do a type def ll long. Does that work? No, it's wrong.
Wrong way around.
Oh, okay. Yeah, I've never used type def basically, except
it's useful to do it to save typing time, which is important for competitive programming, right?
Yeah, that's true. That's true. So basically this give an alias to long, right? So you can type ll instead of long. That will give you the same thing. So that's type def. Right, I think right now I'm going to talk about auto. So in C++, there's also this feature that you let compiler automatically figure out the type for you. So let me just show you by trying to print out the type of this. We have to import a library. I think it's called type info. Yes, type info. Yes. All right, and then you do ID. This should be char name. And let me just delete this. And if I run it, we can see that the compiler, when it's compiling, it tries to figure out what is this auto. And in this case, because we did assign a character to it, it thinks that it's a char. Now, normally I wouldn't, I wouldn't recommend using auto either, just because, first of all, you should know what type your variable are declaring, right? Like you should know. Secondary is that sometimes you might think the compiler think it's this type, but then it's actually the other type, and then you're like, I don't know what's going on because you use auto, and it's actually, yeah, you've actually been using the wrong type this whole time. But yeah, that's about auto. I think. No. Right. What else? Okay. For all those other type of integers, you can actually not type int after those things, because just because C++ already know if you type long, it knows that it's a long int. You could also make a variable read only by doing a const. So for example, I could do const maybe I do double pi equals 3.14, and then later on, if I want to change the value of type, say pi equals 3.15 instead, it's going to tell me that type is read only. This is not modifiable. Right, that's const. Notice that when you declare a variable, you can also initialize it, but you can also choose to not initialize it. Another thing is that you can declare multiple variable within a single statement, right? I should probably talk about statement afterwards. So say if you want to declare multiple variable with the same type, you could do a, b, x, y, z. So in this single statement, you've created 4 variables, all of them with the type int. You can initialize some of them and not initialize all of them, or you can initialize all of them, whatever you want to do. Now, I think, does anyone have any question about types? I am assuming no. Iterator can be asked. Why doesn't it give me notification for chat? I guess it just doesn't do that. Okay. All right. Where's the arrow here? Shouldn't be one. Okay, cool. Let's talk about statement in C++. So a statement, you should already know statement from other languages, but just in case that for some reason you don't, a statement is something that can be executed. So for example, this variable declaration, that is a statement. It could be a expression, so it could be something that has some sort of value. And in C++, every single statement ends with a semicolon. So the result of how C++ separates statement with semicolon is that C++ doesn't care about your indentation, unlike a certain other language such as Python. So because they already have those curly brackets to define when does the function start, when does it end. You already have semicolon to differentiate all of them. This will still compile just fine, because C++ does not care about how you format your code. Right, let's talk about overflow. I thought I'll just show you what happens. Say if you accidentally assign a variable that is outside of its range. Say we have a unsigned. Actually, no. I'll just use G here. Say if I accidentally assign -1 to it, what would happen is that C++ will try to assign -1 to G. It's not going to work out. And if you then later on try to use this variable, right? Say if I want to print it out here, what would happen is that you just get something that doesn't exactly make that much sense. So yeah, the overflow can happen with any variables, even sign, integer, char, float. If you try to assign a value to it that's outside of its range, right? So in that case, C++ is not gonna know what to do. In Java, it's gonna give you error. However, because C++ wants to be fast, it doesn't check. It doesn't check if you accidentally overflow a variable, and it'll just silently give you the wrong result. So that's something that I think people should be careful. Does anyone have any question about overflow? No, I think this should be quite easy, right? Most people here probably already know, since you already know other types of static type language. Right, let's move on to string. Did I prepare? Nope, I didn't. Okay, so this is just to get us started with getting user input from the console. So let me just write a string here. Right, so this is a string literal. Notice that in C++, string cannot be enclosed with single quote. If I enclose it with single quote, it's gonna tell me that, hey man, this is, single quote means a single character, and double quote means a string. Now this is a string literal. So what I mean by literal is that literal is basically value that's written in code. So one example would be 5. That would be a literal. If you are going to do something like int x equals 5, and then if you type x here, that wouldn't be a literal, right? So that's what literal means. We can use the type string by including string from the standard library. We can initialize a string type with this thing. We can this is actually called a single parameter constructor for string. So this is not just a single assignment in terms of initialization, but right now you don't really need to understand it. Hopefully I can get to that if we have time, but we're not exactly doing too well for time. But anyway, initialize a string. We can output a string by doing cout str and line. So that would work. This is a string literal. We can also get a string from the standard input. So cin str, right? I put that wrong. Okay, and then let's print it out again, just so that you guys knows what's going on. Right, so it given me a string literal. Now let's input a string, something interesting, and then it prints out a string. Now notice how this string stop at the space. So this is one behavior of cint, is that cint, whenever you try to take a user input and put it in the variable with cin, it stops whenever it sees the first space, right? I think you can modify this behavior by some means, but I don't exactly know how to do that. And I don't think for competitive programming you need to exactly read an entire line from. But if you really want to figure out, you can search it up. So for cin, let's talk more about cin, console input. Not only with string, you can also get other types of variable from user. So say, let's declare 2 integer here. Let's ask user, give me a number. And then Let's get whatever user input into Cin. Give me another number. And y. Right, so this should be relatively straightforward for most people here, right? You can also use scanf. Yes, you can. You can use scanf and printf in C++. But frankly, those things, I think they did not exactly that convenient compared to Cin. I really think, why did I? Oh yeah, I miss a semicolon here. But yeah, I think since you're using C++, you should be using Cout and Cin, and they are a lot more convenient than printf and then scanf. Let me just print those two variables out. Maybe I do x equals end line, and then I can do a y equals x. Right, I think that should make sense, right? Give me a number. Let's use 7 and 3, right? This makes sense, right? For most people, this makes sense, right? My mom is distracting me now. That's why I was kind of lost my train of thought somewhere in the middle. Right. So this should make sense. Now let's talk about basic operator in C++. I'll just go through them relatively quickly. You should already have seen all of your math operator from other programming languages. Right. So this is all the basic operator in C++. You can plus them together, minus numbers times divide, and this is the remainder operator. So this will get the remainder of x divided by y, right? Let's just run it. Give me a number. Let's do 7 and 3 again. So you can see x plus y is 10, x minus y is 4, blah, 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 blah. All of that should make sense, right? Because I think this is relatively easy. Now notice that x divided by y give you 2. So this is because both x and y are integers. And when you do two operations with an integer, C++ will return you integer always, and C++ will basically do the division and then round down to the nearest integer. We can solve this by doing something called casting. Basically, what we do is that we tell C++ to convert x into a float. Now, if we run it again, we'll see that we get, when we dividing things, we get a floating point number. So whenever, notice how like I only converted x to float but not y to float, so y would still be integer. And in C++, whenever you try to do an operation with two variables of different type, C++ always convert the variable with less range to the type of the variable with a type of more range, right? So in this example here, float obviously have way more range than integer. So C++ will automatically convert this integer to a float and then do operation between them. Does all of that? I think all of that should be relatively easy. Formatting strings. Yeah, well, yeah. This is definitely a lot sexier. Formatting strings. I don't even know how to format things. I think you can do them. You can do them with Cout, and also you can do them with scanf. I think printf. So most people would use printf if they want to format string. But I think, in competitive programming, you don't really format your string, right? You just print out your answer. No, I don't know. All right. Let's keep going. Let's talk about conditional operator, also called, you can also call them comparison operator. Let me try to make this a bit smaller. Yep, okay. All right. Let's talk about comparison operator with if statements. So C++ have 1, 2, 3, 4, 5, 6, 6 comparison operator, bigger than, smaller than, bigger or equal to, smaller equal to, not equal, and equal. All of this should be relatively simple for you guys, since I assume you guys have seen them in other languages. C++ also have, what is this called? Logical operator, I think that's what they're called. This is and, or, and not. You guys should know what's going on, right? So this is a piece of program that I've written while I'm preparing for this workshop. Let's see. It basically, I mean, this program should make sense to most of you guys, right? At this point, you guys should know enough C++ to make sense out of the program. How old am I? I am 20, and I am not a teenager, right? So this is how if statement works. Actually, let me see. Yeah, you can, an if statement doesn't have to exist with the else, so you can get rid of that. And if this is false, you don't want to print out anything, you can just not have an else. And then now if I am 13, I am a teenager. However, if I'm 20, then it just doesn't do anything because there's no else statement. The thing about C++ is that when there's only one statement in if, you can actually not type the curly bracket, right? Because C++, you know, it already, there's only one statement, and when there's no curly bracket, C++ just assume that only one statement after the if is included. So we can see that it will still work. How old am I? I am 18. Everything works, right? Before I go on to else if, let's talk about this really trivial thing called a ternary operator. So a ternary operator is kind of like a mini if statement. The way that this works, say, I have a Boolean, am I a teenager, right? And then let's see if my age is smaller than 20 and my age is bigger than 10. We say yes, otherwise we say no, right? So basically what this does is that first of all, it checks the condition in front of it. If the answer is true, then it returns this value. If the answer is false, it returns this value. Sometimes people use it when they don't want to write an entire if statement for a simple assignment, but you know, you can use this if you want. And let us just print this out. Am I a teenager? Right, maybe I put it. How old am I? I am 21. I am, wait, I did this. Wait, what? Why is it 1? Oh, because this is not even Boolean. It should be a string. Oh my God. Okay. Did someone? Yeah. God damn it. Okay. Oh man. Okay, that makes a lot of sense. Then if this is in another language, they will tell you that string cannot be assigned to a bool. But in C++, they just implicitly convert it to you, and you don't even know what's going on. Right now we get the right answer. Now we get the right answer. Say I'm 12. I am a teenager, according to this. Right. Let me check the chat. Is there some sort of styling guide for computer programming with CPP? Not that I know of, but you know, just follow, just have good coding style. You know, have your indent when you should have indentation. And you know, you can, some people like to put the curly bracket here. That's just a preference thing. People mostly don't care, right? I think the positional curly bracket is like not that big of a deal. Yeah. But yeah, let's I hope good Go coding style is nice. Yeah, yeah, you can also do reformatting code for most of the IDE. Right, I think most people don't have question. I am assuming no question here. This is all relatively basic stuff. Oh man, we are not doing well for time. Let's talk about else if. Do I? Right, okay, this is something interesting that I prepared. So does most people understand what is this code? Like what does this do? People should understand this, right? Should be relatively straightforward. Let me just run it. And say I got a according to the program, I am now average. Okay. Okay, so this syntax for else if is not actually a syntax in C++. It's only because this whole if else statement, this whole thing, this is considered as a single statement in C++, right? So all of those else if things, they are actually nested if else. They're basically if else nested within the else statement, right? It's just because this whole thing is considered as a single statement, you don't have to type the curly brackets here, and you can also format them nicely so that, let me see if I can. Nope, I can't do that. Okay. Wait, what? What's happening? Okay, now it's good. Okay, yeah. So that's basically else if for C++. Now you can see that this else is this if else, it's quite repetitive, right? So you know, we have all of those gray equals. You have you know, it's easy for you to make a mistake here. So let's try to replace it with something that's a little bit more elegant, like these. Huh? Huh? What the? Hello? Can people still hear me? Holy crap, what happened?
Yeah, I can hear you.
Hello?
We can still hear you.
Oh my god, what's happening with Zoom? What? Well, I might have lost recording there. I hope I didn't. I'll find out later. Holy crap! What the hell is that? Just randomly barging. All right, let's talk about it. Let's talk about switch statement. Right. So if you know C, you all know switch statement. Basically the way that this works is that when it gets to this line, it checks grade against all the cases here. It jumps to whichever case that it match, execute the code, and then this break statement basically tell it to break out of the switch statement, right? So it breaks out of the switch statement. Let us just see it works. Say I got a D. I can't go home anymore. All right, so the way that switch statement works means that because switch statement, it basically jumps to this line and then keep executing until you see a break. The things is that, say if you forgot to type a break here, what would happen is that, so I go to D, what would happen is that it basically it just keep executing itself, right? Because it doesn't see a break, it doesn't jump out, it just keep executing the next case, right? So the reason why this is made this way is because, you know, sometimes you want to do something with one case and then do the same thing with another case, right? Say maybe this is somehow intended. You could do that. Another reason why it's made that way is, say if you want to do the same thing for two different cases, you could do this, and then, you know, if grade is D, it jumps to here. If grade is F, it jumps to here, execute the same thing, and then breaks at the end. This is why some people are quite against using switch statement. One person that comes to my mind is the lecturer of foundation of algorithm. I remember when I was taking that course lectures, it basically told us never use switch statement. I'm like, what? Are you sure? Are you sure about that? Are we sure? Are you sure we always want to use if else? Because if else also have, you can also make mistakes in if else. That's quite subtle and hard to see. And frankly, I think with a good IDE, they should color your code, right? So I think with your code color, even if you have quite a long switch statement, it should still be quite clear if you forgot to type a break, right? Because different color. All right, I think switch also makes your code slightly more readable. So it basically shows whoever that's reading the code that we are doing this instead of if else, where the reader still have to check all the if else or the condition to understand what's going on. Right, I think all of this should make sense. They're called default. So default is basically when this doesn't match any cases, it goes to default. It doesn't have to be included. You cannot include it in that case. If you don't include default, it will just not do anything if none of the cases match. Right, I think. Yeah. Oh my God. I think switch does have a place in C++. It makes your code ever so slightly more readable. Using a map, oh man, I don't even, I think I do that with language that doesn't have a switch case, like Python, or I think Java does have it. But yeah, you can also do that with the map. All right, let's move on. I don't think there's any other question. No, this should be relatively basic. Let's talk about loop. Right. Okay. C++ have 3 types of loop actually. I'm only showing 2 of them here. This is a while loop and this is a for loop. I don't think I need to go into too much depth about them. Those 2 loops are basically identical, right? So for while loop, as long as this condition is true, the loop keep executing. For for loop is basically just like another way to write something. Say if you wanna do this specific type of while loop, you can do other type of while. You don't have to have an I here or have an increment here. You can have some sort of other conditions, but it's just here I want to show you 2 identical loops to show you how how there's an equivalent for loop for every while loop and there's equivalent while loop for every for. Actually, that's not quite true. I'll talk about. But there is one very minor difference with while loop and for loop, which I will talk about soon. Right, let me just print this out. Yep, you can see. I hope all of this makes sense. Yes, it does make sense. I think. Yeah, this should make sense. Right. Now before I go to all the shorthand of assignment operator, I want to talk about the third loop in C++, which is a do while loop. So the way that do while, say if I wanna, maybe I can just comment this out. No, this is not how to comment. Okay, now this works. Okay. Say if I wanna, say if I want things to execute at least once, right? 0, 12, 5 is smaller than 0. Say just for example sake, I give you a false condition here, and then let's do cout. This will be executed at least once. All right. Right. So this is, do while loop is basically identical to while loop, except that it doesn't check the condition until the entire thing is executed at least once. I think that should make sense, right? It should make sense. Yep. Okay. All right. Let's talk about let me see. Let's talk about this line. So as many of you already know, you probably already seen this in other languages. There's a shorthand for this, I equals I plus 1. You could instead do plus equals 1, right? This is equivalent to I equals I plus 1. You could also do something like I times equals 1. You know, any operator that you want to do. They have a, you know, all the 5 math operator. They can be written this way. I mod equals 1, right? All of that makes sense, right? Okay, let's talk about how the assignment operator, it actually returns a value in C++. Let me just comment all of this out. How do I? Oh, there it is. Okay. All right. Say. Okay. Let me see how I want to approach this. Right. Let's do something like maybe I can do int x, and then let's try to print out the value of x equals to 10. I just want to show you how the assignment operator, it actually evaluates to something, right? So see, after x has already been assigned to 10, this also get returned, kind of. The entire thing also evaluates to 10. So a few things you can do about this is that you can do something called a chain assignment. So you can go y equals x equals 10, right? What does this do is that, first of all, it assigns 10 to x. And also this entire thing evaluates to 10, and then that then get assigned to y. Let me just print both of them out so that you can see what's going on here. Right, both of them equals to 10, right? I hope that makes sense. One of the implications with this is that, say you have a if statement, right? Say int x equals 0. Let's see, if x equals to 1, I can type out x is 1. Right, so that's all well and good, right? You can see it doesn't print out anything because x is not 1. But say you made a typo here, right? This is why I am also somewhat, you know, against using if in the place of switch statements. That say if you fucked up here, say if you instead of 2 equal, you type 1 equal. Now what would happen is that this thing, even though x is not equals to 1, what this do is that it actually assigns 1 to x, and then it returns 1 to the if statement as the condition, right? And then if statement, it interprets anything that's not 0 as true. So therefore, this thing becomes true. You accidentally modify x even though you don't know it because it's a typo, and then everything else break, right? So this is one thing that you really need to be careful in C++. Now, because I'm using a good IDE, it actually tells me that, hey man, you might not want to do this, you know. So there's the return value of equal operator. Let's not equal operator, assignment operator, and let's talk about plus and minus, as some of you already know from some of the other programming languages. How do I get rid of all of them? I can't do that. Man, I'm not that familiar with using Visual Studio. Most of the time, I use Visual Studio Code. I think that worked before, right? Why doesn't it work now? Oh, it does work, but it doesn't work here. Okay, it does work. Okay. All right. There is a shorthand for these still. and it's called plus plus I. It does the same thing as I plus equals 1, right? And there's also, actually, you know what? I'm going to expand it here. Int x equals 1. I want to point out that the difference between plus plus I and plus plus and, well, plus plus something and something plus plus is that they return different values, right? Say if I want to increment x, while at the same time printing it out, right? What this do is that it will increment x and then it will return whatever is the incremented value back. So we should get 2 instead. Maybe I should get rid of this. I should comment this out again. Okay. All right. So I think that makes sense to most people. However, if you put plus plus after x, what would happen is that it will still increment x, right? Say if I print out x here, it will still increment x. However, it returns the original value before incrementation back to C out. So if I print it out here, you'll see that, you know, it returns whatever x is before increment. So this has some practical use, although most of the time I'll just recommend everyone to just, you know, put plus plus and into a single line, and that would just solve a lot of people's confusion there. We could also do minus minus, same thing. It, you know, it works the same way as plus plus, except it minus equals to 1 instead of plus equals to 1. If I put minus minus in front of here, see that all of this should work, right? So I think that's all. Okay, I have to talk about break and continue. Let me just first of all, let me just change everything to I++. Right, and everything will still work. Right, let's talk about break and continue. Let's see. Say here, actually, let me just get rid of this for loop here. We don't need that anymore. Say you want to, you know, for some reason, after I is bigger than 10, you want to jump out of the for loop. You can do this by doing break. And what would happen is that once x is bigger than 10, it will just break, right? It would go off. This break basically jumps out of the for loop. You can also do something like continue. Say if every single time, if I mod 2 equals 0, so basically whenever I is even, you don't want to execute the rest of the loop, right? Let me just. Right, okay. And then you can run this. You can see that, you know, whenever I is even, it skips over all the rest of these, and then it basically start a new loop, start the next cycle of loop. I think, does anyone have any question about looping? This is actually why you can do. I don't know why you were referring. I actually. Yeah, I'm not sure. I'm not sure. I'm not sure what you're referring to there is. But okay, let's talk about scope of variables. So in C++, oh man, I shouldn't have removed that for loop before. I still need it again. Man, I need that for loop so many times. Okay, so in C++, a variable only exists inside the curly bracket that it is declared in. Say if I do int true here, if true just as example, and then I declare x inside of if statement. If I want to use it outside, it's not gonna work, right? It's gonna tell me that, hey, this is undefined because, you know, the life of this variable only live as long as the code is inside the curly bracket, right? This is actually the only difference between for loop and a while loop is that for a while loop, the I is declared here, right? So I lives this entire thing. However, for the for loop, because I is declared kind of inside the for loop, its scope is only this long, right? So you can only access I inside this for loop, right? Say if you want to do I equals 10, that's not going to work because this I only have a scope of that. So this is the only difference between those two. Does that make sense for most people here? It should. Anyone have any questions? No? Okay. All right, I think I might have taken too long to explain everything that I just did. Let's talk about arrays. You can declare array like that. Declare array with size 10. Actually, I think I have a piece of code. Yeah. Right. You can declare array like this. You can initialize the array. Note that you can also initialize parts of this array here. Sometimes you can not type the size of the array because the you can initialize it and then the compiler will just automatically determine that this have a size of 3. Notice that unlike array in some of the other language, array size can be changed once it is created, right? And array size cannot be a variable. It has to be a integer literal, right? So you can index an array like this. You can access the second element of ys, and you can assign the first element of x's, and blah blah blah. You can do all of that. So I think all of that should make sense to most people here, right? Yeah, y1 equals 2 because in C++, indexing start from 0. So 1 would actually access the second element, and then 0 here because I just assigned it here. It's 10. All right. Right. Note that this curly bracket thingy, it can only be used when you're initializing an array, right? So say if I want to do something like ys equals 3, 4, 5, that's not going to work, right? Because this is only used in initialization. You can also create a multi-dimensional array. You can understand multi-dimensional array as array of arrays. So this is a 2x2 array. I just access the array here. And as you can see, everything works. Right, I think, do people want to take a break from here? Or do you want me to just keep going? Anyone? Oh, okay. All right, I think maybe I shouldn't have spent so much time doing the previous stuff. We are not, I hope we get into some of the more interesting stuff that I've prepared later. Wait, where's the chat? All right, there it is. Yeah, the thing is that I'm actually not gonna talk about smart printers because it's just a class. I was more hoping that I'll just talk through how a class works and then people can just look to the reference. So I'm actually not planning to talk about what is the classes in standard library. Right. Let's talk very briefly about vectors. So vectors, they're kind of like array list in Java. So they come from the library include vector, right? That should, yeah, okay. Now that works. We can see it. Oh no, never mind. This code is not working yet. Okay. We can initialize the empty vector like this. This vector will have an initial size of 0. We can also give it an initial size. Now this vector will have an initial size of 2. We can add a new element to the end of the vector. So vector are basically array that can change size, right? So this would put an element at the end of the vector while also change its size to 3. I can index the vector. I can print things out just like how I do with array. We could also get the size of a vector by doing this. So I'll just show you. Oh, this is broken. How do I? Oh my God. Okay, there it is. Right. So in here, initial size of 2, pushing 3. Now the size of 3. Now the size is 3. Print out this variable that we just assigned here. Print out this element that we just assigned here. 13. Print out this element. that we push to the end of the vector gives us 3. Ask for the size, give us 3. That should make sense, right? All right. There is a lot of other things you can do with vectors. I'm just telling you the basic stuff. Honestly, I was hoping that I have time to go into classes. By the look of things, maybe I won't. But once you understand classes in C++, you can basically look up online how the vector works, and you should be able to understand everything really easy. Let's talk again very briefly about some of the things you can do with string. Again, just the most basic stuff like this. Right, initializing a string, you can index a string the same way that you index a array. So what this does is that it basically puts T, replaces the first character with the capital T. You can add string together, right, and then assign it to them. So this is going to be add to concatenate 2 strings together. You can have another string, add them together, get the length of the string, and then get a substring of starting from index 13 with size 4. Right, I think I went through that relatively fast. Does anyone have any question regarding to string? Does all of this make sense? What is the default value of a vector? It's undefined, I think, or it's 0. Actually, I don't know this. You should probably maybe let's search that up. Default value of the vector in C++. 0. Okay, so it is 0. Okay. It is 0. But the default value of array, I think, is undefined. So if you don't initialize a array, yeah, it's 0. So if you don't initialize an array, it's I think that's undefined. But if you do initialize, if you do a vector, the default value would be 0. All right, I think. Okay. We still have time for pointers. That's good. 4 is still 0. Wait, what does that mean? Yeah, sure, why not? I mean it's right here. I can just share it. Yeah, okay, I will do that. What if you yeah. So vector can, all right, I was gonna talk about template. Well, if I have time to, I hope I have time to talk about template. But you can also actually, I'm just gonna show it here. Vector string. I'm not sure. I think the default value for a string, for a vector string is for a string with vector initialized this way is going to be an empty string. I think I'm not entirely sure. I think that should be the case. You can also do string, and then you can do everything the same way. This is just you can put any type here. You can even do like 2D vectors, vector of vector. You can even do that. I hope all of that makes sense, right? Does that make sense, Alex? Yes, no? But what if you do okay, I think the default value should be what's called the default constructor. Do you know what that is? Yes, no? The default constructor. So in C++, everything has a default constructor. It's basically the constructor with 0 parameters. Does that make sense? That would be the default. Does that if it doesn't make sense, okay, it makes sense to some people, but I don't think it makes sense to everyone because I haven't talked about constructor yet. Hopefully I get to that. But yeah, maybe I'll keep going even after this workshop has ended. Am I still recording? I am still recording. All right, cool. Let's talk about functions. This should be relatively straightforward for most of you guys here. Oh no, this is not how I'm supposed to do this. That's right. Okay. So this is how you declare a function. I just declare a really simple function here that takes two numbers and add them together. This is the return type of the function. So this is basically what type of value does this function return. This is the name of the function, and this is the list of parameter function, each of them with their name and with their type. Right, and I coded this small things to show you calling a function. Right, something. If you do, you see, it doesn't print 0 though. Okay, I think what IDE are you using, Alex? Hello, Alex. What IDE are you using? Okay, so I think this is either a feature in modern C++. So I know that when C++ was just invented in the 1980s, int x, if you don't initialize something, it should still run, but it should yeah, x is declared. So if you declare some variable without initializing it, it should just give you something that whatever the thing that's previously, whatever is already in the memory, it just give you that value. I think it's either that Microsoft think that you should always initialize the variable that it give you this error here, or it's a relatively modern feature of C++. I think, right? I'm not entirely sure, but I have also observed that if you declare something and then use it without initializing it, it actually does not compile. It gives you a compile error. Does that make sense? Yeah. I mean, okay. So in C++, there's this thing called undefined behavior. Basically, if you so in C++, they want to enable compiler to what is the English word for this? To optimize. Yes, optimize. They want compilers to optimize in the best way they think is possible. So they have this undefined behavior. So one example would be to use a variable without initializing it, right? If you use a variable without initializing it, that behavior is actually undefined, right? So different implementation of compiler would give different results. I think this is what I'm saying right now should be correct. So it's just in the case of Visual Studio, because Microsoft thinks that it's better if we give those people an error, and that's what it does. In some other compiler, they might give you a different thing. They might just give you a random number. I remember in 2012, C++ is actually my first language, but I never finished learning C++, even until today. There's still features in C++ that I don't know. When in 2012, or it's 2014, I forgot which exact year it is, I remember doing things such as without initializing a variable and using it, and it still works. So this is definitely a relatively recent thing. Right, let's go back to functions. Let me just run this to show you guys how this works. Yep. Okay. All right. Okay. Give me an x. Let's do 7 again. Right. Okay. So we printed out the sum of those two variables. Right. I think no one have any. Does anyone have any question regarding to this? Let me try to bring it up. No, I am assuming no. Okay, let's talk about forward declaration. Say if you want to put this add nums at the bottom here, and then maybe you want to organize. Maybe you think this is a better way to organize your code, and then you want your main function to be at the top. What will happen here is that C++, it will actually give you a compile error. So the reason for this is that when C++ was invented in the 1980s, compiler are still quite primitive. They're not exactly they're not very, smart. So basically what the compiler does is that it starts reading things line by line, and then it gets to here. You see this add nums and it goes, oh wow, I've never seen this, I've never seen add num in my previous in the line above here. I wonder what it is. It definitely cannot be a function that's appears sometimes later, and I will just toss an error here. So that's how C++ works. We can solve this by doing a forward declaration, basically telling the compiler that, hey, there's this function with this return type and those two parameters that exist, right? I think this should be a semicolon here. And if you do this, then the compiler will read, and then it will see this and it go, oh, okay, add nums exists. And then when it sees add num here, it won't be confused anymore. So that's C 7 plus 3 is 10. That I hope that makes sense, right? Yeah, should make sense to me. I think most of our audience here actually knows C, right? But yeah, let's very quickly talk about global variable. So this is not something that I would recommend you to use. Actually, I think in competitive programming, global variable is used quite a lot, right? Just for convenience sake. But yeah, you can declare a variable outside of any function. You can basically modify it. You can initialize it here, modify it in any code within this file actually. And then I just wrote a small program here. Actually, notice this void here. Void means the function doesn't return anything. For those of you that does not already know, right? We can run this, and we'll see that. See, global equals 10. Print out global. Now global is 10. If we want to call this function will modify global to 90, and we can print out 90 here. Most of the time at least in software engineering, right? I'm not talking about competitive programming here. Software engineering, most of the time they do not use global variables, just because it's kind of hard to track, hard to track a global variable, who's modified it, who haven't modified it, everything like that. So, but I think in competitive programming, people do use global variable a lot, just because in competitive programming, the code isn't exactly that long, and you can just read everything to see when it's global being verified. Right, so I hope that makes sense. Now let's try to do something here. Let's did I have a, nope, I think, wow, I've already, okay. All right, cool. Let's declare a function here that takes in an integer, assign 5 to that integer. I think some of you already know what I'm trying to do here. Let's initialize x to 10. Let's print x out. Let's and then let's assign 5 to x. Right. Does anyone know the behavior of this, the expected behavior of this thing? Anyone? No one? This is too easy for you guys? Does anyone know what this will print out? No? Yeah, okay. I was getting a bit worried. I was just gonna be myself talking here. Okay, thanks guys. So right, we can run it. Right, I think, yeah, most people already know what's going on. So basically, this X, C++, what it do is that it always pass by value unless you tell it to pass by reference. So what does pass by value mean is that when we are passing X into the function, it actually copy this X into this X, right? And then now we change the value of this variable. Those two X, they are not the same X. This X is simply a copy of the other, the X in the main, right? So once we change the value of this variable, it doesn't actually affect the thing outside of the main function. I think this should be straightforward for most people here, right? I mean, most programming language work like this, I think. Right, so this brings us to pointers. Right, I'm getting to the area where I'm not as well prepared, because when I rehearse things, I always start from the very start. So yeah, anyway, let's keep going. Pointers are basically variables that store the address of other variables, right? And the only two operators that I need to explain in order for you to understand pointers is the reference operator and the dereference operator. But before I goes on more about pointers, let's talk about L value and R value very quickly. Right, so L value and R value are two types of value in C++. An L value is something that has a memory address, right? So for example, here, X will be an L value. It makes sense for X to have a memory address, right? Whereas R value is something that does not have a memory address. For example, if I type out A here, this would be a R value, right? It doesn't make sense to have an address for A, right? Right, hope that's clear about L value and R value. Most of the operator returns a R value. So for example, if you do something like, let me just clear another variable here, y equals 7. If you add x plus y, right? It doesn't make sense to have an address for x plus y, right? So x plus y, in this case, it returns a R value. Now, some of the operator does actually return an L value. One of the example would be an index operator. So let me just declare an array real quickly. An array of size 9 maybe, right? And now if I access an element of this array, it does make sense to have an address for the element of this array, right? So in this case, this operator, this was called an index operator. This operator actually returns us a L value. Right. Now we've gotten that out of the way. Let me bring that back. Okay, so to declare pointers, what you do, right? Say if you want to have a pointer that points towards an integer. Actually, I still need x here. Int x 0 maybe. Say if you want a pointer that points towards an integer, what you do is that you put a dereference operator after the integer, right? And what this does is it basically creates a pointer that points towards an integer. Now you can get the address of a variable by doing a reference operator. So this is what reference operator do. It returns the address of x, right? You can assign it to the pointer here. And then I think what I'll do is that and then now I can print out whatever value that this pointer points towards by using the dereference operator. So the dereference operator, it returns a L value. Did I say that reference operator can only be applied to L value, right? Because obviously if something doesn't have an address, it doesn't make sense to get an address from it. This dereference operator, it gets you the variable that this pointer points towards. So if we do this, we can see that it will print out x. We can also modify whatever this pointer points towards by using a dereference operator. Say if I want to modify the variable that this pointer points towards to 10, and then I can print out x here. It should also change to 10. Right? Does anyone have any question? Oh, yes, I was gonna talk about that. Thank you. Right, I guess I was planning to talk about that after showing passing a pointer to a function, but I guess I'll just talk about that now. So the thing about declaring a pointer in C++ is that what you're actually saying in this declaration is when x, after applying dereference operator to pointer, you get the type int. This is what actually this line means. So basically what I'm saying is that, say if you want to declare two variable in the same statement, this y here wouldn't actually be a pointer towards int. This y here would just have the type int, right? So does that make sense to people? Yeah, I am assuming. Yeah. Okay. Yes. So this is. I don't think they should have made it that way. I think the dereference operator should follow the type. However, it's just not the case. I don't really know why, but this is why most people would put the dereference operator with the pointer. Right. Okay. Let's modify this function so that it actually does what we do. We can take in a pointer pointing towards an integer. Let's change the name here. We can modify whatever this pointer is pointing towards to 5. And then let's see if I can. Oh, got that. Okay. If I can int x 0, c out x and line, and then 5 to x, we pass in the address of x using the reference operator, and then we print out x here, and x should change. Yes, okay, it did change. All right. Well, I think is that clear for pointers? Does anyone have any? Yeah. So that would be totally true here. I really wish that they just consider this as an entire type, but they just don't. So that's why you might want to put the dereference operator with the variable name. Yeah. All right. Before we move on to something that's really fun, let's talk about reference. All right. Reference in C++, the official explanation for reference is that they are alias for other variables. Let's try to create a reference here. So to create a reference, say you want to create a reference to an integer. This is what you do. You use the reference operator. Note that, why did I use the same name here? No, okay, this is better. Note that a reference has to, you have to tell the compiler, because this is an alias to another variable, right? You have to tell the compiler, what variable is this alias of, right? So let us do that here. So this means and reference has to be initialized. I can do something that's similar to pointer. Maybe I see out. Maybe I can modify this here, and if we see out reference, and we also print out x, both of them should change because at this point reference is basically an alias of the same variable. Does that make sense to everyone? Does anyone have any question about reference? I'm guessing yes. I'm not sure what is your question, but yes. Yes, and maybe the dereference operator should have followed that. And maybe even this reference operator should follow the variable name. But in this case, I'm actually not sure. I have never ever used reference in my life just because there really isn't a need that ever arises in reference here. And frankly, I haven't even work with C++ for that much. Right, we can also take inner reference as a function, right? So in this case, instead of, let me just change the name here so that it's more clear. In this case, reference can replace pointers. Maybe you think it's more elegant. I think otherwise, because reference for me is it's just too implicit. Like it's not, for me, it's like it's not clear enough. When you're using a reference, whether you're modifying some other variable or you're just modifying a single variable. Right. Let's assign 5 to x. However, this is a maybe more elegant way to write this. Instead of putting a reference operator here, this is also how cin works. So cin takes the reference of the variable that you pass to it. And yeah, okay. So the way that I understand reference is that they are pointers. Reference are just pointers, except they act as if they are the variable that they point towards. Does that make sense? This is how I understand reference. Does that? I'm not sure. I hope. Okay. Okay. Reference are just pointers, except they act as if they are the value that they point towards. This is how I understand reference. Yes. So when maybe yeah, I would say it's like Java. But yeah, this is basically reference. So in assembly language and even in C, there's no reference, right? So when C++ compiles a reference into assembly language, it basically turns it into a pointer. So reference, just understand it as reference is still pointers, except they act as if they are the variable that they point towards, not the value. Sorry, they are the variable that it points towards. Does that make sense? Reference it. If you have a pointer of x, okay. Let me actually try to answer this question here. If you have a pointer of x, okay. Say if I declare a pointer here, pointer of x, right? What do you mean by reference it? And then you reference it. What does that mean? Do you mean as like, and then I reference x? Is that what you mean? Or are you talking about referencing the pointer? Hello, Isaac? Oh, okay. You reference the pointer. So I think this is what you mean, right? Is this what you mean? Dereference? I don't know. Yeah, okay. So interesting thing, it gave me an error. I thought this would work. Okay, apparently pointer reference cannot reference pointers. Who would have thought of that? I thought differently, actually. It doesn't even allow you to do that, basically, but you can. I did not expect this. I thought you can reference whatever value that pointer points towards. So in this case, you're referencing x. If you modify this reference here, say you give it variable 9, and then you print out x, this should still print out x. It should print out 9 here. I think just that. Yeah, I know, right? Honestly, I like most of the stuff that I'm going to teach you guys, like such as reference and L value, R value, dynamically allocated memory, and multi-dimensional array. I learned that as preparing for this tutorial. Right? C++ is just so complex, just so many things to learn. All right, let's do. Okay, I really want to do this thing. That. Okay, actually, yeah. Okay, let's talk about how arrays kind of behave as if they are pointers. Right, say if I create an array here, x is 10, right? And I've always talked about, access in those array, blah, blah, maybe access 5, index in the array. I never talked about what is access, maybe, this is not a good variable name. What is a good variable name? X is so difficult to pronounce. Can someone give me a good variable name? A, yes, A, okay, thank you. A, okay. So I've never talked about A with itself, right? So when you do A by itself, I can actually print this out here. C out A. When A is by itself, it kind of acts like a pointer. So this is a pointer pointing towards the first element of the array. Does that make sense? Yeah. So A basically A acts as a R value of a pointer pointing towards the first element of array. Does that? I'm not sure if that makes sense. Yes, exactly. Yes, except that A is not actually an L value. So A by itself, it does not actually have an address, right? It's when compiler compile this, it just replaces A with whatever the address is, the first element of the array on, I think, on the stack. I think. So what does this mean is that when you are indexing an array, right? Say if you do this, there is a equivalence of this using the dereference operator, and that equivalent is that. Right? Those two things are exactly identical. Does that make sense to people? Yes? No? I hope. Yeah. So those two things are exactly identical. I think that's all I have. No, I have. Okay. So another thing about array variable by itself basically being pointers is that you can actually pass an array to a function. Say assign first 5. I assign the first variable of A to 5. Right? This variable can basically get converted. This value can basically get converted into a let's initialize part of it. Initialize the first variable to 1, the first element to 1, and then let's call assign first 5 A plus A, and then if I print out the first element again, you will see that it has changed. Does that make sense? Does that make sense to people? Yes. Yes. I'm hoping that I explained it well. Maybe not as structured as the previous part of the course. Right. Let's move on. I've been waiting for this moment. I prepared something that's really interesting for you guys. Let's say how am I going to call this function? Maybe I call it maybe that's what I call it. It doesn't take any parameters, and what it returns is a pointer towards an integer. I'll declare this inside. I'll declare an integer x, assign 10 to it, return the address of x. Now let's go out here and let's go int ptr equals return ptr to 5. Oh, got that. And then let's print out. Why does it? Oh, I did the wrong type. Okay. And then let's print out whatever. Yeah, I should really start doing it this way. That is a bad habit. Let's point out whatever value that pointer is pointing towards. Now, does anyone know what would be the output of this? Anyone? Just a single number, shouldn't be too hard to type. Or you can unmute yourself. No? No one knows the output of this? Yeah, it is gonna be. I was gonna talk about that. Yeah, it is gonna be 10. All right, so it is 10, right? And you know, everything seems like as if they're working well. Let's try something else. Let's say we have another. Wait, this is not 5. I did the name here wrong. It should be 10 because I am returning to a pointer towards 10. Pointer 15. And what we do the same thing here in y equals 15, except we do 15 returns the address of y. Now let's call this, nope, int pointer 2 return pointer 15, and then let's see out 2. Anyone knows the output of this? What would this output? I hope this works. Anyone? Someone have to say something. 15, 14. Okay, that's I'm not sure where. Maybe that's a typo, but I have a lot more than still prepared. Actually, maybe not. I prepared like 9 pages of script. We've already gone through 6. Yes. Let's see what would happen. So Isaac is right. Maybe I comment out this line just to avoid some confusion. Right. Even, oh, wait a minute. That is wrong. I should have put this. Wow, I did a typo here. Right. Even if was that, wow, maybe, wow, I asked the wrong question before. But you know, basically my point is that after you return pointer to x, pointer towards x out of the function, x is also already deallocated, right? As Isaac has said here. However, now this pointer points to a piece of memory that used to be 10, and because no one has gone to modify it, this will still print out 10, right? However, now we call this other function here, and we assigned 15 to y. Now the memory that x used to occupy then get allocated to y, and y writes 15 to it, so that even if we point out the pointer that's supposed to point to a value of 10, it actually points to 15. Does that make sense to people? It turns out to be way less exciting than I planned it to be because of that typo there. Does that make sense? Yes? Yes, I am assuming I am. Yes. Okay, thank you. So this is something that is quite interesting. Now, yeah, God damn it. Always because just because of the typo, man. I prepared for this. All right. Yeah, so a pointer, this pointer here, because the value that it points towards has already been deallocated, this is actually called a dangling pointer, right? So this pointer is pointing towards a piece of memory that is no longer being occupied by anyone. And this is something that's actually quite dangerous in C++, because you know someone else could use that memory, modify it to something else, and then you print it out and you're like, why does it print out a different thing? I have never modified this. You know, it's something that you need to be careful of. Now note that the behavior of dangling pointers is actually also undefined in C++. So this output here, first of all, this output depends on the compiler actually allocating the memory that X used to use to Y, right? So that depends on that. If it allocates some other memory, it will still be 10. Or if someone else, yes. Oh, why does the value of Y ends up in the same place as where X was stored? Because when this function finishes itself, X doesn't exist anymore, right? X is already dead. Well, yeah. And so when we call this new function here, it just so that happens that Y happens to be allocated the same memory as X. Yeah, this is something that relates to stack. I was gonna talk about stack after I talked about this, but you know, it just so that happened that Y is allocated to the same piece of memory because I tried it before. This is not guaranteed. Y is not guaranteed to be allocated the same memory as X, but most of the time it does, because as Daniel said here. Yes, I'm gonna talk about dynamic memory soon, right after this. Wow, we are running out of time. Okay. Does all of that I just talked about make sense here? Dangling pointers. Is this example? Yes, I said dangling pointers. Did I say dangling pointer or did I say something else? Okay, cool. Okay. Let's keep going. This is the we're getting to the part of the workshop where I haven't exactly rehearsed. There's an avoidable moment. Yeah, that's true. So let me smart pointers. You should definitely look up about smart pointers after this. I actually don't know how smart pointers work just because I don't really use C++. I actually do use Java in my competitive programming. But yeah, smart pointers, do look it up if I eventually get to classes. Right. Oof, this is a long workshop. Let's talk about dynamically allocated memory. Right. Do I have? Yeah, this is. I supposed to use this piece of code to extend pointer, but I just forgot to copy it. Yes, C++ reference. That is a great site. I was gonna maybe mention that, but I kind of forgot. Okay. So to. All right. Okay. Okay, so recall that array size have to be known at compile time, right? It cannot be an array size has to be a yeah. Okay. So yeah, where was I? Recall the array size. Yeah, recall the array size has to be known at compile time. Well, there is a type of array. Wow, the chat keep happening. Maybe I should just the answer is maybe. However, I was planning to teach you guys about classes and template just because you will use classes written in the standard library, right? So it's helpful that you actually understand how those classes and template works to understand so that when you're using things from a standard library, you don't get too confused. Right. Okay. Let's talk about dynamically allocated memory. Right. So there is a type of array whose size doesn't have to be known at compile time, and that's called a dynamic array, right? And I'll just give you an example here as I talk about stack and heap. All right. C++ has two pieces of memory, two types of memory, stack and heap. Stack only holds variable, right? So the way that stack works makes it so that whatever sits on the stack, their size has to be predefined, right? Their size have to be known at compile time. And in fact, that's why the array size has to be a literal, it has to be a constant, because array does sit on the stack in C++, at least static array does. Because it sits on the stack, and for stack, anything that sits on it has to, the size have to be predefined. Another thing about stack is that it's automatically managed. So, compiler will automatically get memory from the stack. It will automatically deallocate memory from the stack whenever there's the end of the curly bracket. Whenever a variable goes out of stock, the memory that it takes on stack is free. So this is the example that we just saw with the function here. Now, there's also this other part of the memory in C++ called a heap. So a heap works differently. You can get any amount of memory that you like, as long as it's not too big that it's bigger than the physical RAM. And you ask compiler for, I think maybe compiler, maybe operating system, for a piece of memory on the heap, and then you get this memory. And the thing about heap is that the memory on the heap does not get deallocated unless you tell it to, right? So heap is manually managed. I hope it's clear for most people. No one have any question about stack and heap, right? No, okay. All right, so let me just explain the new keyword. So what new does is that it gives us a pointer pointing towards a freshly allocated memory on the heap with a specified size. So how much size a memory you want depends on the type of the memory, the type of the thing that's going to occupy this memory, and also this length here, right? So here, what I've done here is that I've created a dynamically allocated array, right? Does that make sense? Maybe. I'm going to assume yes. You can also DA2. You can also do something like that. So what this do is that it basically gets enough memory for a single integer, and then it returns the pointer to the single integer back toward this pointers, right? Does anyone have any question regarding that? How do you feel? Yes, okay, I was going to talk about that. So to free a pointers pointing towards a piece of memory on the heap that's allocated with this syntax, with the squarey bracket here, you do delete EA. This is how you do things. And then after that, this piece of memory will be freed. It could be given to other things, other pointers, etc. If you want to free something here, right, what you do is that you do delete and no squarey bracket DA2, right? So if you accidentally use delete on something that's allocated with this syntax, you will get a runtime error, and vice versa. Right. And another thing to talk about freeing a memory is that after you free a memory, those pointer, they now points towards a memory that's already deallocated, right? So what you want to do, how do you delete 2D? I will get to that. I will get to 2D array soon, right after this. Okay. So because this is now a dangling pointer, it's recommended to set the pointer to nil, right? So nil, I hope I'm pronouncing that correctly. Nil in C++ basically means that this pointer doesn't point towards anything, right? It points towards nothing. And in that case, it avoids you from accidentally accessing some memory that you're not supposed to, as we've seen with the function example here. Right. let me show you how we do 2D array in C++. Array 2D, two-dimensional array, or you could do any dimensional array you want. So the way to do a two-dimensional array is that you first of all you allocate an array of pointers, right? Does that make sense? Yes, it is. I hope it is recording. Something weird happened in the middle that might have lead to us losing some recording. Hopefully that is not the case. But yeah, this is how a 2D array works. Now you have this array of pointers, right? What you do is that then you use a loop to individually allocate a array of integer to each of the pointer in the array, right? So I plus plus, and then you go a 2d I equals new int. Let's say 3. Actually, let's change everything to 3 because that will make it easier to explain later. Did I? Oh, okay. Does that make sense to everyone? Yeah. Yeah, I think, yeah, I thought that I prepared way too much. Maybe, I think I'll stop. Oh yeah, I forgot a semicolon here. I'll stop once there's less than 8 people in the call, because at that point, I feel like the amount of people is too small that I probably should just stop and just ask you guys to learn classes and template by yourself. All right, all right. So let's talk about difference between this array. Actually, let's change the name to A and B, because this is the name that I use on the slide that I used to explain this. Let's talk about a dynamically allocated 2D array. It doesn't have to be 2D, by the way. It could be more than two-dimensional, versus a statically allocated 2D array. So I drew this really pretty picture here to show you the difference in data structure in terms of dynamically allocated array and statically allocated arrays. Right. So as I've said before, dynamic allocated array are pointers pointing towards a first element of an array of pointers, and then each of the pointer in this array then points towards other arrays. I think that should make sense to people, right? However, when you allocate a two-dimensional array with when you do a statically allocated two-dimensional array, what C++ does is that it actually still gives you a one-dimensional array with the same size. It's just that it pretends to be a two-dimensional array. So you see here, what we actually get in the memory is a one-dimensional array of size 9. Does that make sense to people? This is how C++ does, because when it gets compiled to compiled to assembly code, this is what happens. Does that make sense to people here? Okay, thank you. Okay. So what this means is that recall that I said, let me just refresh you guys' memory with this. Say if I have an array, with size 10. Recall how I said, when you index in this array, right? Like it is equivalent to using the dereferencing allocated on the address plus whatever your index is, right? Does everyone still remember that, right? I'm gonna assume yes. Okay, yeah. All right. So here comes the trivial part about 2D array, dynamic allocated 2D array, and statically allocated 2D array. Say I want to access the first row No, sorry, this is not, this index star 4 is 0. The second row, second column here. The equivalent of this, because this is dynamically allocated to the array, the equivalent of this is with the dereferencing or allocator is first of all a plus 1, dereference it, and then plus 1, and then dereference it. Okay, does that make sense? Maybe I'll replace this with I and J, just so that you guys get a better picture of what's going on. Does that make sense to people? I am assuming yes. Okay. All right. Now, however, if I want to index this statically allocated to the array, say I want to do the same thing, I, J. When this gets compiled, it actually translates to something like this, right? So the equivalent that is I think I times 3 plus J. Because statically allocated to the array are essentially one-dimensional array. Does anyone? I think I might not have explained that well. Is anyone confused? Does anyone have any questions? I'm gonna wait for like at least 1 minute here. Okay. Is no referring to question or no understanding? Okay, cool. So okay. Let's move on. So what this means is that, why is there an error here? Okay, doesn't matter. So what this means is that, say if you want to have a function, right, that takes in a two-dimensional array. Nope, that is wrong. I think, why does it? Yeah. Any array may not have minimal this time. Wait, can you do this then? Oh, I think you can't take array as you have to put pointers, right? Okay, so say if you want to take in, say if your function wants to have a parameter of a 2D array, this is actually not going to work, because 2D array, this B here, it gets converted to an integer pointer, not a pointer to pointer, unlike a dynamically allocated array, right? So that's one of the trivial things that. Okay, thanks. But all right. I think, well, we still have 10 people, so yeah, okay. I think I'll at least try to get to classes. So yeah, so if you want to take in a dynamically allocated to the array, you have to do pointer of pointers. However, if it's static allocated to the array, it is just one pointers. I hope that makes sense to everyone here. Yes, does that make sense? Oh man, it's supposed to end 8 minutes ago. I just prepared way too much. Yeah, okay, thank you. All right. This is the part. Now we're getting to the part where I have not prepared at all. Let's talk about classes. Actually, no. Before I talk about classes, let's talk about template. I think that might be more important than classes. Say if you want to make a function that returns a Boolean, right? And it takes in two integer A, integer B, and what you return is if A is smaller than is smaller. Does all of that should make sense, right? I could potentially call it here. Maybe I have int A equals 9 and b equals 10, I can print out this smaller a, b. Now that's all good and well, right? Right, so you see it returns true, which get printed out as 1. Right, now, however, this thing will only work with integers, right? So say, let me try to find an example that would not work here. Maybe let's try float. I'm not sure if C++ will automatically compare float. It does. So what happened here is that those two variables, even though they are floating points, they actually got automatically casted to integers. Let's try this, right? What about that? I think this should show my point here of how this function does not work with float, right? So even though a, which equals to 9, is smaller than b equals 9.5 here, this still return false because a and b get converted into integers before comparing them, right? And this is obviously, we can write something for a float version as well. We just write something for every single type. Obviously, that's not what you want to do here. So one thing you can do in C++ is to have a template function, right? And basically, you are writing one function that can fit for every class, right? Say this template is class T. We can replace all the type that we use with this T. Now, how template function work with C++ is that whenever you call a template function, right, you have to tell C++ what is the type of this template function, right? So say for here, we want to call a float version of the template function. What happens is that obviously template doesn't exist in binary code, right? What happens is that C++ see this, right? This guy have called this function with float as t. What it does is that it automatically generates a function replacing t with float, and it calls the function here, and we can see it working. Does that make sense? Yes, during compilation. Yes. So this is not dynamic. It's during compilation. That's why I think this type. Well, obviously, this type has to be known at compile time. Does that make sense? Here, everyone. So what this also means that say if you call the same template function with different types, your compiled, your binary code, the execution program that gets compiled will actually get slightly bigger. Obviously, very slightly bigger because it's a small function. But imagine if you have a huge function or a huge class, which I will get to soon. It will get bigger. Does this make sense, everyone? Does anyone? Yeah, it's like generics, except I think generics in other languages like Java, they do not generate different function every time it get called. Except in C++ it does. So this is how everything works underneath. Yeah, template is like generics. Is this? Yeah, okay. All right, cool. Okay, so this is template. Let's talk about classes. I have not rehearsed this at all. I have not rehearsed class at all. But I have prepared some examples. So let's class. Right, for those of you that don't know, I think that most people know. Yeah, class is basically user-defined types with that is made up of other types, right? So say we want to define a class of book. This book has some public variables. We have a title, we have a author, we have a num page. Say that, right? And then we can create a book, just like this, book, and then we can access their member variables and initialize them with using this. I think I forgot what this operator is called. If someone knows. Oh. Oh, okay. Okay, thank you. Okay, okay. All right. Struct. This is funny because struct is absolutely identical to class. It is the same thing. Struct and class, those two keywords are the same thing, except that in struct, if you don't specify something, it will be public, as Alex has said there. Whereas if you declare something in class, it will be private. Does that make sense? Right. So we can access them. Maybe J. I don't even know how to spell her name. Book, say this is Harry Potter book. And then this book have a page, number of page of 500. Right. I hope this makes sense to everyone, right? Yes. I mean, you should have already seen classes in other types of languages. Right. I am assuming it makes sense. We have very little number of participants now, but I think I'll try to keep going, even though I haven't exactly prepared for this long, just for the recording people. Right, okay. You can also dynamically allocate a class by also using new. So new book, and this will dynamically allocate a book from the stack, I mean from the heap, and return its pointer. Right, and then you can access the member of this book by using the dereference allocator. So you first of all you dereference the pointer, and then you can access the member here. Right. Now you might not want to do this dereference allocator every time. So there is a shorthand for this. Well, or rather a more elegant way to write this is that you just put an arrow here, right? So what this does is that it's basically the same thing, right? This works on pointers. So both of them works the same way. Did I spell this right? I hope I spelled that right. This is going into a recording. Right. Let's see. Actually, I think I'll stop once the participant gets to 7, because frankly I didn't even prepare this that well, and I'm not my thought is not that clear now. Okay, let's talk about constructors. So in C++, right, everything a default constructor that does absolutely nothing is implicitly declared. Right, so this is, even before writing this default constructor is already here, and the default constructor gets called whenever you don't specify what constructor to call. So one thing to know. Oh, okay, I think I should stop now. Okay, I mean, yeah. I'll just tell you guys some other things that you should probably learn yourself. I mean, we've gone over 20 minutes over time anyway. After that, I was going to talk about default and parameterized constructor. This is the thing that you should probably search up by yourself, since I'm not going to continue this tutorial anymore. Also constructor will always be called. We have two-way. You have like 6 different ways. No, 3 different ways to call constructor. And also also, I was gonna do a template class, and I was also going to do operator overload. So I think what's gonna happen now is that, I mean, frankly, I'm already like 5 minutes late to my next workshop. So what I'll do is that just everyone look those things up on YouTube or something. Yeah, you know, C++ is so massive. I think I've taught everyone what they mostly need to know to do competitive programming with C++. Initializer list, yeah, I think initializer lists are just what are they? They are constructor with variable arguments. So these are like in C++, a function can have a non-fixed amount of argument, right? And initializer list, I think fundamentally, when you try to implement an initializer list, I think they're just variable argument constructors. Does that? I'm not sure if that makes sense. Maybe it does. Maybe it doesn't. Okay. For the remaining 7 participants, well, 6 except me. Do you guys have any question before I close this workshop and leave? I think we're not gonna do another workshop. Next workshop is, you know, next Tuesday, and it's not gonna be hosted by me. Thank you. My name is actually my preferred name is Richard. Sean is only my legal name. So a lot of people, even people in the competitive programming club committee doesn't know that. They just call me Sean. Thank you. Yeah, I think hopefully I did well for everyone here. I try to actually teach you guys something useful, so that, you know, I taught things that doesn't really appear in YouTube tutorial, like the differences between static allocated 2D array and dynamic allocated 2D array. A lot of YouTube tutorial, they try to simplify things and stuff. But yeah, I think that's all. And I will stop sharing. I hope